Infrastructure as code? It sounds like something you get if you mixed a sysadmin, a developer, too much alcohol, and waited 9 months. But it's actually pretty clever stuff. In fact, I would go as far as to say that if you're deploying to the cloud and you're not using infrastructure as code, you're doing it wrong. Welcome back to the Pro Tech Show, the place for tech tips and advice for IT pros and decision makers. Infrastructure as code isn't limited to the cloud, you can do it on premises too. On-prem though, you need to decide whether it's worthwhile having a set of infrastructure to manage your infrastructure. Is the overhead of having this management layer less than the time it saves you? The answer to that will depend on the scale of your infrastructure as well as how repeatable it is. By that I mean, does every server do something different, or are you frequently rolling out more of the same? The reason I'm going to focus more on the cloud in this video is because whilst you can make an argument to do infrastructure as code on premises, in the cloud it's getting really close to being a no-brainer for a lot of workloads. The key difference is that debate about whether the infrastructure overhead is worth the benefit just doesn't exist in the cloud, because the overhead is handled by the cloud vendor, it's part of their platform. So with a lot of that hard work already taken care of for you, the case becomes very compelling indeed. So what is infrastructure as code? Allow me to show you. I'm going to jump into Azure for this. You can do this with AWS and Google as well. In fact, the tool I'm going to use works with all of them. Let's quickly create a Windows virtual machine. I'm just going to fill in some basic details here, nothing fancy. This isn't the best practices guide, I'm going to blow this all away when I'm done. It's just to show you the process in case this is new to you. I will fast forward the video at certain points because watching this deploy in real time is going to get boring quickly. There you go, there's my virtual machine. You see, I also have created some other resources as I was going along, like networking and a disk for the operating system. I'm not even going to bother booting this up, I'm just going to clear it all away. The point of this was simply to show you what the normal way of provisioning resources in the cloud looks like. Now I'm going to show you what it looks like using infrastructure as code. I'm going to use a tool called Terraform to do this. Terraform works across different cloud platforms, so if you use a mixture of AWS and Azure, this is a great option for you. We can define the same resources in a text file. There's my networking, the virtual network, subnet, the network interface, and here's the virtual machine itself with its operating system drive. Let's add in a SQL server and a database while we're at it because why not? If I run Terraform, it's going to take that infrastructure configuration I've defined and it will go and build it in Azure for me. I appreciate I'm skipping over a lot of detail here. This isn't going to be a Terraform tutorial any more than it's an Azure tutorial. I've got some interesting concepts I want to introduce you to, so watch to the end, and if you find this as exciting as I do, then go find a tutorial and learn to do it yourself. Here we go though, we've got our new virtual machine and our SQL database resources provisioned automatically. Now, already this might have your brain turning over. There are possibilities for saving time here, but we're just getting started. Repeatability is another great benefit. I can take that file that defines my infrastructure, run it in dev, test and live, and bang bang bang, 3 perfectly replicated copies of my infrastructure. Or maybe instead of a dev, test and live setup, I need to provide some kind of self-service provisioning to customers or internal business units. Maybe I want to set up a lab or training environment that needs to be blown away and recreated on a regular basis. If I've got the solution defined in a Terraform file, it can be quickly sprung up at the click of a button without the end user needing to understand how it fits together or how to actually build it. Hold that thought though, let's talk scalability. Let's say instead of 1 database and 1 virtual machine, I need 3 databases and 5 virtual machines. I can change just a few numbers in my Terraform file here, run it again, and there we go. 3 databases and 5 virtual machines. Obviously they're not connected to anything, there are no load balancers or firewall rules for starters, but you get the idea. I can define all of that in the Terraform file as well, but frankly I doubt you want to sit there and just watch me write code for the next few minutes. You'd rather use that time to click the like button and subscribe to this channel, I suspect. Okay, so this is fast, it's repeatable, it's scalable, it's basically a script, right? No, it's not a script, it's a blueprint. Let me put it a different way. A script is like a set of directions. Straight for a mile, left at the lights, third turn on your right, etc, etc. That's fine, but directions are only useful if you're starting from a specific known location. If you give me directions to get to the supermarket from your house and I try to follow them from my house, I'm going to get lost. If you give me an address though, I can pop it into my satnav and it will figure out the unique set of directions I need to get from my starting location. That's basically what Terraform does. The infrastructure definition I give it is my desired end state, the destination address, my target infrastructure. Terraform figures out what changes are needed to achieve that target and applies them. Let's say I don't want 3 databases and 5 virtual machines, I want 4 of each. Let's update my Terraform file. If this file was just a script and it blindly created whatever was in it, then when I ran it, I'd end up with 7 databases and 9 virtual machines, which isn't what I want. I could delete everything that exists before running it to start over, but that would be destructive and wasteful. Instead, if I let Terraform generate its plan, it tells me what it's going to do. It has figured out that to modify my current infrastructure to achieve my desired target, it needs to add 1 new database and destroy 1 existing virtual machine, so that's what it's going to do. The Terraform file isn't a series of steps, it's a definition of my target infrastructure and it's written in code. Let that sink in. How do developers store their code? In source control, we can do that too. If all of our infrastructure is built using Terraform, it's essentially self-documenting. If we keep it in source control, then we can accurately version control our infrastructure and track changes to it. How many times have you seen something stop working and it was working yesterday, so what's changed? Nobody knows. Everybody is always mysteriously quiet when this happens, aren't they? If you build your infrastructure from code and the code is version controlled, you can see exactly what has changed. Not only that, but if version 2.3.4 has a problem and you need to revert, you just run the file for version 2.3.3. Terraform will figure out what changes are necessary to get you back into that known good state, and it will go make that happen. This has implications for disaster recovery as well. If you've sat any technical exams, one of the questions they love to ask is what is the minimum amount you need to back up to be able to recover your service? Of course, in the real world, you probably don't back up the minimum amount. Yes, if you only back up the data itself, it is possible to rebuild all of the infrastructure around it, but by the time you've done that, how badly has the business been impacted in the meantime? So normally most of us probably back up everything so we can just hit the emergency button and restore everything. Well, that's a luxury that costs money. If you've got your entire infrastructure defined in a file, there's your infrastructure DR plan. You just need your data and somewhere to run that file. Okay, to be clear, disaster recovery planning is a lot more involved in that, but being able to type Terraform apply and have your entire infrastructure just rebuild itself automatically, that's really going to help. Funny enough, another benefit of infrastructure as code is how quickly your infrastructure can be destroyed as well. Now, why would you want to destroy your own infrastructure? Well, take this stuff I've just built for your benefit. If I leave it there, it's costing me money and I have no need for it once this recording is complete. If I run Terraform destroy, it will go and remove all of that infrastructure it's created, returning me to 0. Except not actually 0, and that's important. I have other resources in Azure that I really don't want deleted by accident. If I have a Terraform file for a specific solution, I can safely and completely decommission that solution without affecting anything else running by using the destroy command, which is what I'm going to do here. If I need to show this to someone else or my video messes up and I need to re-record it, that's fine. I can run Terraform apply and bring it all back. That's one of the really nice things about infrastructure as code and a way it could help save you money in the cloud where you typically pay by the second. Now, we can't talk about infrastructure as code without mentioning DevOps. DevOps. There, I mentioned it. Come on, let's be honest, if DevOps is your thing, then you were sold at source control. One thing I haven't really talked about is the configuration inside the servers themselves. This is where you may have come across technologies like Puppet, Chef, Ansible, and PowerShell DSC being mentioned. There is some debate about terminology here. Some people would say that spinning up servers and serverless infrastructure components using code is infrastructure as code, and managing the configuration inside those is configuration as code or configuration management. There is valid logic to that. The two sets of tasks occur at different levels in your infrastructure and generally speaking use different tools as well. You might use Terraform to build the servers and network components, then Ansible to manage the configuration of the servers and switches. There's a bit of overlap, but usually you'll have a clear divide of these tools build the infrastructure and these tools manage the configuration of the infrastructure. That said, both of these tasks would typically sit within the remit of an infrastructure team, and whether you call it infrastructure as code or configuration as code, the concepts are incredibly similar. The best way I can summarise this is that infrastructure as code and configuration management are different entities, but both fall under a general umbrella called infrastructure as code. I appreciate that can make it a little confusing to understand what exactly someone might mean when they use the phrase, but that's where the world seems to be with it. So far, everything I've mentioned falls into this section of the diagram. As for the configuration management side of infrastructure as code, I think that's going to have to be another video. Comment below and let me know if that's a video you'd like to see. As for this video, I think it's time to bring it to a close. Hopefully this has given you a taster of what might be possible. Let me know if you've switched using infrastructure as code and share the good and the bad that you've experienced from it. If you found this useful, hit the like button and consider subscribing if you haven't already done so. YouTube has popped another couple of videos up here for you. Go ahead and check those out. If you like this one, they might be your sort of thing too, because I made them. Thanks for watching, guys. See you next time.